I'm Bob Eyers. I'm responsible for, as product manager for turning, mill turning, and on-machine probing. I will give an overview today of the what's new in NX85 and focus on the turning side. I will start with doing an overview of what's new in NX85. The functionality that we have introduced in NX85 ranges from simple UI changes, which help the user in workflows to create new operations and NC programs, all the way to a new operation type to help you in creating toolpaths, removing the blank skin. I've chosen to show this functionality based on the turning workflow. So not the way things are presented is not based on how important it is. It's just how do you find it within the turning workflow. I will be starting from the definition of turning work planes and then creating operations and continue going through the process. The first step in creating any turning NC program is defining the turning work plane and defining the tool axis that you're going to use. So NX85 introduces a preview functionality which shows the resulting work plane and rotational axis that will be used within the turning operations. This preview appears as soon as you select the MCS spindle. You will see a dotted line, which is the turning axis, and you will see a plane showing what is the actual plane you're working in. This is immediately updated as soon as you start redefining. So if you switch your lathe plane for ZM to XM-YM, you immediately notice that it changes direction for the rotational, and you'll see that there is a different work plane defined. The same if you start moving your MCS. Let me move it outside. You'll get an updated view, so you can see that what you're defining works or doesn't work for your product. In this case, choosing this will not make sense. This functionality basically helps you to quickly set up the work plane and removes the necessity to try several times and see every time whenever you update the workpiece what the effects will be. Improvements that we've made is not just within the functionality of showing, it's also in generating. The NX85 version contains many quality enhancements for the span outline. We've introduced a better generator, and we improved the backup. There's alternative ways of working with the span outline which generate a good backup result. It's not just that the quality has improved of the generator, you will also notice that the span outline in quality has improved, resulting in better toolpaths in the end, because there will be less intermediate points generated for all the motions. The step that I want to show next is the UI enhancements that we made for the create operations. If you create new operations, we have now added tooltips to all subtypes that we have available. Those tooltips show a picture and explanation of what the purpose is of each subtype. Those tooltips can be also added by you. So if you have your own customization with your own set of types and subtypes, you will be able to create the same tooltips with the specification and for yourself, so that you will be able to define and explain to your users how to use the operations. This is not for just milling, it's for every type that we have added. Another change is for when you are working within the operation, it's the length of the names. We have allowed or increased the length of what you're allowed to enter in such a way that you can now enter names which are up to 132 characters, which is a big increase from the earlier 32. It gives you the ability of making more clear what's your operation. Another change that has been made is the way how you can position objects within the operation navigator. You now can just drag them, and you will notice that as soon as I move it, there's a darker line appearing which exactly shows where will the operation be. If you pay attention, you notice that the length of the line in the front depends on where you are. If you're in between a tree, it will be a short one, indicating it will be at that position. If you move outside, you will notice it will be longer. So in this case, you will see if I put it in this position, it will be the first. If I move it, and you notice that it's a longer line which extends to the front, it will be the following operation. The change that has been made is also that you're now allowed to drop any item to the front of the list. So you're not restricted anymore to where you're going to drop it. Within the functionality, one of the important new enhancements is the addition of a new operation type. Within any turning operation, at the moment you were limited to the contour of the part. This is most of the time sufficient, except for when you try to remove irregular casting skins from the blank. For this we have now added a new roughing strategy. If you compare it with just a normal linear zag operation, you'll notice that this operation is really following the contour of the part. But if you switch to the blank contour zig, you'll notice that this gives you the opportunity to just following the contour of the blank. You yourself don't have to redefine this. The choice of the operation defines to the processor that it will use the IPW. This is in all sense a normal operation. So it is depending on IPW. If you have a previous operation before which already removed a piece of the material, it will adapt automatically. It is all in all other senses a normal operation, so you can define your limits, you can define your engage retracts, and the system will react to the change. The operation itself has, for its strategy, only two parameters. The step in depth that you have between the passes and how many passes do you want. The system will detect when it will, with those steps, remove too much material and will skip the areas it cannot handle. Another change in the UI has been the ability to switch off the selection of the IPW. In many cases, once you have worked on the turning part, you want to know how much material is still there. We've added a new select to the IPW functionality, which by default is switched off, and at that time when it's switched off, you cannot select the IPW. This to prevent you from selecting unintentionally the IPW whenever you are defining points within the operation. Once you switch it on, you're able to use the IPW to measure distances between the IPW and blank or IPW and part and get the results that you want. Important changes have been made in the quality of the roughing operations. We were very successful in how we remove material, but there were some smaller issues where within an operation you would have recutting of an area which already in previous passes was cut. For example, if you notice, there's here a face has been cut, which will be recut on this level. This is something you don't want to have. So the system has been updated that we now remove all those recutting in roughing. Whenever you regenerate those operations, you will notice that the same pass will go and cut the original level and then will retract once it reaches the same area. Other optimization has been in the calculation of the levels. With the variable average and the variable maximum, in some situations there were cut volumes left where the part just was a little bit too low and couldn't create a level anymore. Those areas normally were removed whenever you switched on the cleanup, but that's no longer necessary. Whenever you generate those, the tool levels of cut depth will be modified in such a way that the part now will remove a lot more material than in previous situations. Within the definition of NC operations, one of the important steps is selecting and adding your tools. And specifically for turning, one of the issues which you have most of the time is you have your turrets with the capacity of the tools. In a turret, normally every pocket just has the room for one, or maybe if you have added devices, 2 tools. To help you in not assigning too many tools to the same pocket, the pocket definition has been enhanced with the capacity. This capacity defines how many tools are allowed in a pocket. And once you have a tool in that pocket, it is not possible to add new tools in it. You have always the ability to overrule it, in which case the system detects that it's possible to add new tools. The next new feature which has been added is an improved control of how do you finish your part and how you handle situations where you have a facing and you have a corner. You have the option to control how the corner will be included. You have the option that it will be combined with the faces. So the cut that creates the face will also contain the cut of the corner. You have the choice of combining it with the diameters, in which case the corner will be combined with the diameter cut, or you can choose to have it split between the two, or even completely skipped. If you choose to have a split somewhere, that's the ability to define an overlap. This overlap is the extension of the second pass. If you see, with an overlap of 0, both passes of the tool will reach the same position. If you now define a distance to overlap, the second pass will be extended. So the first pass will still go to the previous position, but the second pass will go a little bit further. This helps you in preventing cracking for the product. The option to define where will the change be is also overruled by the definition of the stop position. In that case, you're able to work outside of the corner. In that case, you have the choice between using a distance, in which is from the split point in the middle of the corner, moves it around to the first cut, where you also have always the possibility, if you're, in this case, the first cut has been selected to be the diameter followed by the faces, you always have the ability to switch those by redefining the angle, in which case also the stop position will be updated. So you now notice that it's on the face. Other option is the percentage cut, which based on the first cut, in this case 50%, will move it to exactly the middle. Or the one which gives you most control is by defining a point. In this case, the point can be either associative to your part, or you just can define it anyway. It will be projected on the face it belongs to, and there the changeover will happen. Another change for the towards corner is the ability of including a little bit of extra cut. Normally, the towards corner is just doing diameters and faces, but doesn't continue a little further outside. We've added a couple of simple ways for you now to be able to include. The easiest one is include adjacent chamfers and rounds, which includes the toolpath to include the first chamfer or round that's directly connected to the faces. The other option is to go toward the containment geometry. In that case, you can define by either one or two trim planes how far the system should go, and the toolpath will extend to either the region or to whatever position the material finishes. If you check on the top, it reaches the containment. On the bottom material, there's no material left, so it will stop earlier. An important change has also been in the control of tracking points. Controllers have more and more options in how to work with tracking points. If you remember within NX, each cutting insert has 4 radii, and for each radii you can define a tracking point cluster. This tracking point cluster is a set of 9 points which you can select, and which is the point that follows the toolpath output in the NC coordinates. This is very powerful software to use, but with all the options that are now available in the controllers, we've added some new abilities to define how this tracking point cluster behaves with rotations of the tool. Those options, if you look for this situation, we have a tool which is defined to use the P3, which is in the front, sticking out, basically touching the lines or the crossing point of the touch lines horizontal and vertical. We've introduced 3 ways how the system will handle any rotation of the tool holder. The first one is the fixed. This has already been available in previous time. What happens in this case, if you reorient your tool, the tool cluster is not changed, the insert is radii is not changed, and the whole definition remains exactly the same, which means that in this case the tool will still be using P3, and you will notice that the tool path now starts not on the outside touching, but on the inside. Another one is rotate with holder. In that case, the whole cluster rotates with the tool. It's a little graphical displayed here. In this case, the whole cluster has rotated around. The system is still using the P3, but you will notice that there will be a difference between the tool because it's still using the original touching lines from before the rotation. A last new option is automatic. In that case, the system checks if it's still logical to keep the same tracking point. The whole cluster is fixed, but the system will decide, depending on the orientation, if it needs to change tracking points. In this case of the rotation, it moves to a new tracking point P8, and if that's not defined in your tool, it will create one. This tracking point change depends on how is the tool within the definition of the axis. As long as it stays within a quadrant, it will not switch with the tracking points. As soon as it starts switching over to other quadrants, the tracking point will be moved around. Getting back to the end, it is also reaching the end of the functionality that we've added in post-processing. We've added improved functionality for cycles. Already in Annex 8 we introduced the Cycle 95 functionality, which is a big difference to other cycle definitions in the sense that instead of defining how is the tool path, the Cycle 95 is using how to follow the boundary. We're describing this for the Siemens Cycle 95 functionality, but basically this is also available for the Fanuc, who have a similar cycle which generates a roughing operation based on the contour which is passed to the operation. A new functionality is within the cycle of threading. We now have a support introduced for the Cycle 97 of Siemens, which is included in the out-of-the-box. Again, it's not just limited to the Cycle 97. What we've done is added extra MOM functionality, so you get a better access of testing those parameters that are important for defining the operation in the post-processor, and gives you the ability to check on results. For example, in this case, I just generated an operation, changing it to a cycle, and the system detects that the parameters are not matching what the Cycle 97 expects, so functionality has been added to detect that it's there and to warn you for that it's not working. This was a very quick overview, which I finish with two issues that I just really quickly show. It is for the situation which you have when you're having multi-spindle support in your machine. Within the whole set of controllers that we support, the operations always depend on what does a controller support. If you're having the same tool working on the left spindle or on the right spindle, some controllers allow different working coordinate systems to work with. Others require one definition of an MCS for both sides. Flexibility has been added to better control this, and this is defined in the tool in the MORTAP. There has always been a spindle group definition where you could choose between having spindle 1 or spindle 2. The new option has been added, which is operation. What's the difference? The MCS spindle 1 or the MCS spindle 2 really links this tool to always output, no matter if it's on the left side or the right side, it will output and C code based on MCS spindle 1. If you now, instead of choosing one MCS spindle 1 or MCS spindle 2, you select operation, now the output is defined on where is the operation within the geometry view. So for the operation under MCS spindle 2, it will be using MCS spindle 2. For the operation that's using MCS spindle 1, it is using the MCS spindle 1. So you don't have to adopt the setting anymore. This was the quick overview of what has been added for turning specific. If you're working more with mill turn, there is some other functionality which is really interesting to have a look in. One of the new functionalities within NX 8.5 has been adding a volume-based 2.5D milling. This is using an IPW aware replacement of face milling. It is a very powerful new operation, and we already have an existing tech tip showing more about this. Other new functionality which is really interesting is the feature-based enhancements which has been made to NX 8.5. For both feature teaching, which allows you to define your own features, and your operation teaching, which allows you to, based on existing parts, define how you want to manufacture similar feature types. There has been enhancements which are very valuable for the turning and mill turning area. This topic on itself is too large to do in those 20 minutes, so I just want to mention it and want to close off with this presentation. With that, I return it to the general team for any questions on this topic of what's new in Annex 8.5. And I thank you for